So using the kinetic model of gases, explain why the pressure exerted by a fixed mass of gas increases when its volume is reduced at a constant temperature. So once again, we're going to have to look at our gases and we need to see what is causing our pressure. So we remember that this is due to having many particles that are in random motion. So these particles will be colliding with the walls of our container, and this leads to pressure. So what happens is that when we decrease our volume, we start to see an increase in the density of our particles. Basically, we have more particles per unit volume. This thing here is going to increase. And when you have more particles per unit volume, that means you have more collisions every second. So more frequent collisions are going to take place. And when you have more frequent collisions, let's just compare a case where you have one collision every second and another case where you have 1,000 collisions every second. Well, the case where you have 1,000 collisions every second, you're going to see a much greater force being exerted on the wall of your container. And one important point is that when we talk about pressure being exerted by a gas, we are talking about the average pressure that is being exerted, because we have so many different particles and each collision is going to exert a slightly different force. So what we actually measure is going to be the average of all of these forces. When you have more frequent collisions, the average force over time is going to be a lot greater, because when you consider a certain time period, the total amount of force that's being exerted will be greater as well. And that is why our pressure is going to increase. So to put this nicely, when the volume is reduced, the number of particles per unit volume increases. Therefore, the gas particles collide more frequently with the container walls, and this results in a greater force exerted on the container walls.